to another video of Daishinfinity. This is a first video of my YouTube channel. It's a first video, and I create math content for math hobbyists or math people who need math help. In this channel, I am going to introduce many things, such as the L'Hopital's rule, the limit theorem, the central limit theorem, and many different linear algebra proofs and different stuff that will help you widen up your knowledge of mathematics. For information, I am German and half Japanese. I make this content because I want many people to be inspired by mathematics and to love the math. And I also want to help you guys to get the deep knowledge of mathematics. It is also a very important information to say to you guys that I also have two other channels. The other channel is the German channel because I speak German and explain all these same topics, same videos, but just in another language. And I also have a channel called Daishinmas for the smaller kids, which goes from class 1 to class 12, where I explain all the school subjects in German. So this video we're talking about the L'Hopital's rule. If you know the L'Hopital's rule states that the limit where x approaches a is a number. Let me write L'Hopital's rule first. Where x approaches a number a, and a can be anything, where from f of x divided by g of x is also the same limit as when I take the limit where x approaches a of the derivative of x divided by the derivative of another function g of x. So it's called f prime of x divided by g prime of x. And before we start, I want to give you some kind of information that should be there, and if it's there, we can use the L'Hopital's rule. So the first information is when f of x, when we have f of a and g of a, that these equal 0. This means if we plug in 0 just directly inside, then we would get f of a divided by g of a is equal to 0 divided by 0, and this is an indeterminate form, so we're going to divide by 0, which is a problem, so we are not allowed to do this. What we are allowed to do is take the limit where x approaches a number a, and when we do that, we can try to calculate this by plugging in smaller numbers for a, closer numbers for a, I'm sorry. Or we can just plug in the a into the derivative of f and g. Now, since I already talked about the definitions, I'm going to prove this definition. So let us prove this definition, and before we prove this, let us come back and recall a very important equation, that the limit as x approaches a of f of x minus f of a divided by x minus a is equal to the definition of a derivative f prime of a. So to show this in a graph, I can show you a function f. And the function f looks like this. Let's just assume the function f looks like this, and we have the number a. So we have the number a, we put it over here. Let's say a can be any number, can be negative or positive. Now f of a should be on the y-axis, so we have the point P, a, and f of a. And we have another point Q, which contains x and f of x. I'm going to put the x, which is bigger than a, so I'm going to put x is bigger than a, and f of x is in this graph bigger than f of a. It can be smaller, it doesn't really matter, because if it's smaller, it means the gradient is negative or smaller than 0. So x must be greater than a, which means f of x is also greater than f of a. Now, every time we have 2 points, we can build a line between these 2 points, and we get this line. This line is called a secant because it goes through 2 points, but we would like to have a tangent which represents the gradient of the slope of the line at one specific point of the function. Now, we can do this if we let x approach a. So we're going to let x approach a, and when we say that x goes all the way to a. Now the distance between x and a will be smaller and smaller, but it will not equal 0. So if I say the absolute value of x minus a is always bigger than 0, right? Because the distance cannot be equal to 0. So I cannot put an equal sign on to this inequality. So that we have this information, we can start to prove things. So let's prove this. The limit as x approaches a of f of x divided by g of x. Now, since we have the information we had in the beginning that f of a and g of a are both to 0, we can kind of subtract and add 0 to it and substitute f of a and g of a. So we have f of x minus 0 divided by g of x minus 0. And since 0 is f of a and g of a, we can plug this in. And we have the limit as x approaches a of f of x minus f of a divided by g of x minus g of a. Now, since we have this, we are pretty close to getting the formal definition of the derivative at a point a, f prime of a and g prime of a. We only have to divide by x minus a. As you see over here, we have a x minus a at the bottom. So I would like to spread out or factorize or multiply both the numerator and the denominator by 1 over x minus a. This will not change anything, only if 1 over x minus a is equal to 0. Now, 1 over x minus a is never equal to 0, and x minus a cannot also equal to 0, but x is approaching a, so we don't have any problem. So if we do this, since we always take the limit, we are not even having a problem about the denominator being equal to 0, since it approaches it. So we have f of x minus f of a divided by x minus a, all in brackets, because I want to show it to you that we can turn this into another thing, g of x minus g of a divided by x minus a. Now, since we have a fraction on top and the bottom, we can split the limit into the two fractions. This limit theorem I have proven on another video. Go and look at the channel so that you can see it. So we have the limit where x approaches a of f of x minus f of a divided by x minus a, dividing the whole thing by the limit as x approaches a of g of x minus g of a all over x minus a. Now, since we have the definition here and here in the denominator and the numerator, we can both say that this is actually equal to the limit as x approaches a of f prime of x and g prime of x. So in the end, we are stating, or we have proven that the limit as x approaches a of the normal function f of x divided by another normal function g of x, where g of x is not equal to a, is just equal to the limit as x approaches a of f prime of a divided by g prime of a. Very, very nice. since I have proven this, the video is ending right now. I hope you enjoyed the video of Daishinfinity. I'm going to put a little proof box here so that I have proven this thing. And we will see us in the next Daishinfinity video. See you.